In 2008, in a remote Siberian cave, a tiny fragment of a pinky bone was discovered, which would change the world. DNA testing revealed an ancient human species that, to this day, we still know so little about. Who were this mysterious human species we now call the Denisovans? Why did they disappear? And how do they live on inside us? Hi, I'm Louise, an archaeologist, and in this video I'm going to be trying to answer these questions. You can find a written version of this video with references and further reading linked in the description below, and be sure to like and subscribe for more archaeology content. Our story starts in Denisova Cave in the Altai Mountains in southern Siberia. The cave is named after a hermit called Denis, who lived there in the 1700s, but the inhabitants have a much longer history. Excavations in 2008 unearthed a tiny pinky finger bone fragment, which was dated to be between 30 to 50,000 years old. Originally, the finger was believed to be Neanderthal, who had been previously known to frequent the cave and nearby areas. However, in 2010, DNA sequencing revealed an entirely new lineage of ancient humans. This is one of, if not the most significant contributions of ancient DNA research to date. A tiny pinky bone fragment led to an entirely new species. Other Denisovans were also found to have occupied the cave from around 200,000 years ago up to 30 to 50,000 years ago. Currently, Denisovans have only been unearthed in Siberia, China and Laos. However, in April 2025, it was announced that a jawbone discovered off the coast of Taiwan is also of Denisovan origin. There's also genetic evidence for them though found across Asia, with some modern populations carrying Denisovan DNA. But more on this later. Discoveries are happening constantly, so this information is changing all the time. But we do know that Denisovans seem to live from around 200,000 years ago up until 40,000 years ago, with Denisova Cave fitting nicely into this time frame. This means they also coexisted with other hominid species, including our species, Homo sapiens, but also Neanderthals, Homo florensis, Homo loensis, and Homo erectus. It's apparent they endured a vast range of environmental conditions, from the harsh conditions of the high altitude Tibetan plateau with temperatures of minus 30 degrees all the way to the other extreme in Southeast Asia with balmy subtropical woodlands where they would have lived alongside water buffaloes. Along with Neanderthals, Denisovans are our closest known evolutionary relatives, splitting from our ancestors roughly 600 to 800,000 years ago. They are more closely related to Neanderthals though, splitting from them much more recently, around 400 to 500 years ago. And scientists have identified at least 3 different branches of Denisovans in themselves. D0 living in Siberia and East Asia, D1 living in New Guinea and nearby islands, and D2 found in Oceania and parts of Asia. And it's been suggested that these different groups of Denisovans may have been as genetically diverse as one another as the species as a whole with Neanderthals. The fossil record of Denisovans is incredibly limited and mostly consists of teeth and small skeletal fragments. Just 15 Denisovan individuals have been accounted for at the time of filming. But like I said, discoveries are happening all the time, and I've had to edit the script for this video multiple times just to account for these new things coming out. 10 of these individuals come from Denisova Cave. We have Denisova 3, who kickstarted everything with the pinky bone fragment, which is identified as belonging to a 13.5-year-old girl and dated to 76.2 to 51.6 thousand years ago. We've got Denisova 4, an adult male with a molar identified and dated to 84.1 to 55.2 thousand years ago. Denisova 11, nicknamed Denny, an arm or leg fragment, identified as belonging to a 13-year-old girl, dated to around 90,000 years ago, and more on Denny later. Denisova 8, another male with a molar identified, but dated much earlier to 136.4 to 105.6 thousand years ago. Denisova 2, another molar, there's a lot of teeth in this, but belonging to an adolescent girl and dated to 194.4 to 122.7 thousand years ago. Denisova 13, a skull bone fragment, and then we've got Denisova 19 to 21, which are undiagnostic bone fragments, dated to about 217,000 years ago. And these 3 bone fragments have identical mitochondrial DNA, which means they could have belonged to either one individual or maybe 3 separate close maternal relatives. And finally in Denisova Cave we have Denisova 25, a male molar dated to 200,000 years ago. And one analysis of the mitochondrial DNA of the Denisova Cave individuals has suggested that Denisova 19, 20 and 21 are the oldest, followed by Denisova 2, then Denisova 8, and then Denisova 3 and 4 roughly living at the same time. Bashir Karst Cave is located on the northeastern edge of the Tibetan Plateau and is also a Tibetan Buddhist sanctuary. where two more Denisovan individuals were discovered. We've got Xiao 1, a jawbone dated to 160,000 years ago, making it the earliest hominin fossil found on the Tibetan Plateau. And this was discovered in 1980 by a monk meditating at the site and published as Denisovan in 2019. Then we also have Xiao 2, a distal rib fragment dated to 42,000 years ago. And then finally, there are 3 other Denisovan individuals discovered at some other locations. In Laos, a molar was discovered in 2018 that belonged to a young Denisovan girl aged 3.5 to 8.5 years old, dating to 164 to 131,000 years ago. Prior to 2008, on the coast of Taiwan, a mandible known as Penghu 1 was recovered by fishermen. This dates to 100,000 years ago and was originally hypothesized to be Homo erectus, or another hominin species or Denisovan. However, in April 2025, analysis of the protein sequences confirmed it belonged to a male Denisovan individual. And there is just one more Denisovan individual that is the most recently published, but I'm going to be saving that one for later in the video. The identification of Denisovans from so few fragmentary remains demonstrates the extraordinary power of archaeological science. Some of these remains were identified from the ancient DNA, but when DNA couldn't be used, protein analysis has helped with the identification. The DNA has also informed us that Denisovans likely had dark skin, dark hair and dark eyes. And from the limited remains, we've managed to infer some features, which include a low forehead, a protruding jaw, wide skulls and longer dental arches. Like Neanderthals, Denisovans interbred with our species, Homo sapiens, and the evidence for this comes from the traces of their DNA in modern human populations. People in Melanesia have up to 4 to 6% DNA from Denisovans, and mainland Asians and Native Americans have up to 0.2%. This shows the potential geographical range that Denisovans occupied where these meetings could have taken place. There's also some genetic advantages from the Denisovan DNA. For example, a genetic mutation from Denisovans found in Tibetans and Sherpas has been attributed to them for being better suited for higher altitude survival. Furthermore, it's been suggested that Denisovan DNA may have influenced modern human immune systems, especially in Papua New Guineans who hold the Denisovan gene that helps with their immune systems. Denisovans not only interbred with Homo sapiens, but also with Neanderthals. DNA sequencing of Denisova 11, or DENNY, revealed that this girl had a Denisovan dad, but a Neanderthal mum, making her the first discovery of an ancient human hybrid. Her Denisovan dad also had some Neanderthal ancestry, possibly as far back as 300 to 600 generations before his lifetime. This is a very lucky find, but the fact that 1 out of the 15 Denisovan individuals we have identified is a Denisovan Neanderthal hybrid suggests that these hybrid children may not have been a rare occurrence. As it's proven that our species of Neanderthals interbred, it's really no surprise that Neanderthals and Denisovans could interbreed as well, especially considering that they are evolutionary much closer related. The admixture of DNA is such a fascinating area, and I think more mind-blowing finds will come from this in the future. For example, a 2019 study suggested that through genetic studies and artificial intelligence, that there's the existence of an unknown human species in the genome of modern humans, which is not Neanderthal, Denisovan, or a hybrid of the two. Denisovan culture is difficult to pin down due to their occupation at places overlapping with other human species. Denisova Cave, where we have most of our Denisovan evidence, was also occupied by Neanderthals, so it can be hard to determine if materials attributed were Neanderthal or they could have been Denisovan. However, some stone tools have been suggested to be Denisovan, and animal remains indicate they may have eaten deer, horse, bison and woolly rhinoceros. However, at Bashir Kar's cave, there is no evidence for the presence of other hominins of Denisovan layers. Therefore, our analysis of the faunal remains can offer us a glimpse into Denisovan life. This analysis showed us that Denisovans exploited a wide range of animals that were present in the grassy landscape. Caprine animals, which include sheep and goats, became especially prominent in hominin occupation, with them comprising over half the assemblages in some layers. Analysis of their bones also indicates systematic butchering and the use of bones for tools. The remains of other animals were also used in similar ways, and these animals include snow leopards, hyenas, wolves, golden eagles and pheasants. So Denisovans on the high altitude Tibetan plateau made full use of the animal resources available to them. Comparison with other Denisovan sites has found their faunal remains to be comparable with their respective geographical environments, demonstrating that Denisovans seem to have had a high level of adaptability. Now this part of the post especially, I had to entirely re-script because the debate I was going to discuss was settled just last month, and this just demonstrates what an exciting time this area of archaeology is having. In 2018, a relatively complete skull nicknamed Dragoman was recovered from China. The finding dates to a minimum of 146,000 years old and was published in 2021 as a new species of ancient human, Homo longi. Now, the story goes in 1933, the skull had been discovered at the riverbank of the Songhui River by a local labourer building the Dongjiang Bridge in Harbin for the Japanese-aligned Manchukuo National Railway. The labourer recognised the potential importance of the find, likely because of the sensational discovery of the Peking Man, a Homo erectus fossil, just a couple of years earlier in 1929. Due to this importance, the labourer hid the skull from the authorities in an abandoned well. Then in 1945, the Soviet invasion of the area ended the Japanese occupation, but the labourer concealed his former employment from the authorities. He therefore could not report the discovery of the skull, or he would reveal his ties to the former government. In 2018, before he died, his grandchildren learned of the skull and recovered it from the well. Later that year, a paleoanthropologist persuaded his grandson to donate it to the university to study, where it has been ever since. However, the authenticity of this story has been heavily questioned. Ji Chang, the paleoanthropologist, believes that the man claiming to be the grandson in the story actually invented the story because he actually discovered the skull and did not report it to the authorities, so he had to fabricate a lie to get himself out of any legal trouble. Nevertheless, it is a pretty incredible story. Homo longi has been hypothesized to be the same species as Neanderthals, however some have argued that they are different species. At this point in the video, I was going to go into this debate exploring what it could mean if it were Neanderthals, we'd be able to see their face and have a large intact fossil remain to study, but alas, we don't know. However, in 2025, mitochondrial DNA and proteomic analysis confirmed that this skull is Denisovan. This study by Fu et al. Discovered that the Dragoman's mitochondrial DNA falls within the variation of previously sequenced DNA from Denisovans. The Dragoman individual is also similar in age to the older Denisovans from Denisova Cave, and the Dragoman's mitochondrial DNA tends to be associated with the mitochondrial DNA of these older individuals. This further shows that the Denisovans inhabited such a large geographical range in Asia, and this finding will hopefully help to identify other specimens as Denisovans. For example, fossils from Dali, Jinushan and Hualongdong exhibit morphological traits similar to those in the Dragoman skull, making it plausible they may also represent Denisovan populations. The Denisovan shell mandible also shows morphological similarities to some later East Asian fossils, such as the Denisovan Penguin, but also the Chinese Homo erectus, which is another interesting question to be explored, that where do these sort of all fit into the evolutionary time frame? Another interesting question is that how do Homo florensis and Homo ensis fit into this evolutionary picture, who were down in Oceania in similar times? Denisovans seem to disappear from the fossil record between 40 to 50,000 years ago. However, it remains unclear exactly when or how they became extinct. Possible causes may include competition with Homo sapiens, assimilation through interbreeding, or environmental pressures. But however they went extinct, their DNA lives on in lots of people today. I personally think Denisovans is one of the most fascinating areas of human evolution to explore today, and the research is ever changing their story. Thank you for taking time to watch this video, and I hope you enjoyed it. Please let me know what you think about Denisovans in the comments below. Please also be sure to subscribe to my YouTube channel and like for other archaeology content. I'm also on lots of other social media channels that you can find all linked down below. Have a great rest of your day, and I'll see you in the next video. Goodbye.